right, so good morning, good afternoon, everybody. We've got an audience across the continent today, and my name is Jesse, and I am your virtual adventure guide here with Exploring by the Seat of Your Pants. Welcome in, guys, as we continue to celebrate and showcase such amazing people and places around the globe. Now, here, we are all about bringing conservation, adventure, and science into classrooms around the world, and today, we're really epitomizing that. We started off live in the Falkland Islands with Joe and the Darwin 200 team. We hung out with Dr. Beth Mortimer talking about spiders and elephants, Leo Richards in the Abyss, and now we start a duo of incredible programs with NASA engineers with one of my very favorite people we ever bring on the broadcast, Dr. Abby Fraeman. So she is a NASA project scientist who's worked on such amazing and iconic vehicles as Curiosity, Opportunity, and more rovers exploring another world. It really never ceases to get old for me that we have robots that are on another planet, and not only that, that you can see the things that they collect, the pictures that they take within days and within the next day sometimes. That is one of the most crowning achievements mankind has ever accomplished. And I'm so excited to have her on today to talk a little bit about her amazing work. Before I bring her on, a quick housekeeping note. If you're live with us on YouTube, if you're live with us in StreamYard, you guys want to join us in our Kahoot today, we are going to have a quick 4-question quiz between the talk and the question period at the end. So feel free to put in that game pin. I will share that at the end as well. So without further ado, joining us in Pasadena, California, at the Jet Propulsion Laboratory, one of the world's most storied and iconic research and engineering facilities, Dr. Abby, thank you so much for joining us again today. Oh,
hello, I'm so excited to be here.
I'm so excited to have you. I know you've got a lot to tell us today, so if you want to dive in with your presentation, feel free to bring that up, and we will get underway.
All right. Let me go ahead and share my screen here.
You are set. I love this first image. I've always had. It's so good.
Oh, fantastic. Yes, an astronaut rappelling down a cliff on Mars. Well, hello, everybody, and welcome. I'm so excited to be able to visit with you all virtually today. My name is Abby, and I will be telling you a little bit about my work exploring Mars. So even though I work on Mars, I actually physically work here on Earth. I work at a place called the Jet Propulsion Laboratory, which is one of several different centers of NASA. We're located in Pasadena, California, which is on the west coast of the United States, right outside of Los Angeles. NASA isn't actually just one specific place. It's actually a whole bunch of different research facilities around the United States. Different facilities specialize in different sorts of activities. There's the Houston NASA Center. They specialize in all of the astronauts and the human space flight. So if you know the famous line, Houston, we've had a problem. Those are astronauts talking to the NASA facility in Houston. A lot of the rocket launches happen at the NASA Space Center down in Florida in the southern part of the United States. But us here at NASA's Jet Propulsion Laboratory, or as we like to call it, JPL, specialize in robotic exploration of the solar system. If it's a place that humans haven't or can't visit, we'll be there with our robots to check out what's going on. Of course, my favorite place and my favorite planet in the solar system to study with these robots is Mars, which is known as the red planet. It is the 4th planet from the sun and our solar system neighbor right next to Earth. Why do I study Mars? Why do we think Mars is an important thing to spend our time exploring and looking at? Well, first of all, we think Mars might be able to help us answer the biggest question I think that we can possibly ask, which is whether we're alone in the universe. We think billions and billions of years ago, Mars and Earth were probably pretty similar. And we know at that period in time, life started on Earth. So the question is, if the conditions were the same on both planets, could life have also started on Mars? And can we find evidence of that? We haven't found evidence of life on Mars yet. But if we can, and we find out that life started 2 places in the solar system independently, that's going to be huge. And that's going to help us really understand that probably of the thousands and thousands of planets we see in our galaxy, life is probably a common process. Now, the 2 planets were very similar billions of years ago, but today they're very, very different. And Earth's a great place to live. We've got lots of oceans, we have breathable air. But Mars has no atmosphere, or very, very thin atmosphere. It's very, very cold. It's very, very dry. So another reason we want to understand Mars is to figure out what is it that made Mars such an icky place to live today and Earth such a wonderful place today. And if we can understand answers to those sorts of questions, it will also help us better understand for other planets that we're finding, planets around other stars, what are the factors that might make some of them evolve to become much more nice and happy for life like Earth, or much harder places to live like Mars. And then, of course, I think a very exciting reason to study Mars is the potential that one day humans might visit Mars. It is a place we think we could explore with astronauts to study and to do research on. And before we're ready to send humans to Mars, we need to understand the kinds of environments they're going to face, the kinds of hazards they might face, and also what kind of resources might be available to them that they can use when they get there, live off the land on Mars rather than having to bring everything with them. Now, to study geology on Earth, which is what we like to study on Mars, on Earth, it's pretty great. We get to go on field trips. We get to go to all sorts of wonderful places on the planet to go look at the rocks. We can get down into the dirt and crack the rocks open with our rock hammer. We go to places like Iceland, deserts of the American Southwest, and we can use all of these tools that have been developed for hundreds of years by geologists to study the rocks and to understand their history, how the rocks formed, what happened to them after they formed, what that tells us about the climate of the place that we're looking at. On Mars, we can't really do that yet. We don't have humans on Mars yet. So instead of doing geology with our boots and our hand lenses and our nose in the dirt, we've sent fleets of spacecraft to fly by and to orbit Mars. This is just a small sampling. It's a little bit out of date, actually, of all the missions that have either attempted to go to Mars or actually successfully orbited Mars. But from orbit, we can learn a lot about the planet. We can take amazing photographs of the planet. We get pictures like this from our orbiting satellites that show the layers of the rocks on Mars. These rocks may have been laid down in an environment that was once a lot wetter than the environment we see today. You can also see all of these modern day sand ripples that the Martian wind has blown and carved in among these layered rocks. And in fact, here's another picture from orbit that I think is really beautiful. This is a big Martian sand field. And just a fun fact about Mars, the sand on Mars is actually black. It's not kind of light colored like most of the sand here on Earth. It's black. And that's because it's made up of bits of broken up volcanic rock. There are some places on Earth where you get black sand, places like Hawaii and Iceland. And so it's alien, but it's not that alien. And I just think it's so beautiful to look at. Another thing we can do with our orbiters is actually even pull out the composition of the rocks that we see on Mars and understand the minerals that are present. Here's an example of a very special place on Mars called Jezero Crater. You can just sort of see the rim of the crater, but what you can see is this kind of sinuous looking channel that's coming in, and then it's forming this big fan shape. And we think this was actually once an ancient river that formed what's called a delta. It emptied into a lake, and it made this very distinctive kind of funny looking feature. But the different colors here, these are not the colors of Mars. Mars isn't very green or purple. What these colors are the representations of the kind of minerals that are on the surface that we've mapped from orbit. And we can tell that these are the kind of minerals we would expect would be associated with environments where you had water and rivers and lakes. And in particular, we see things like salts. We see things like clay minerals. We see all sorts of things that we know really only form when you have liquid water that is interacting with the rocks. Now, studying Mars from orbit, that's great, but my favorite way to study Mars is with our robotic geologists that we've sent to the surface. So there have been several rovers at this point now that have landed on Mars, but kind of the first real geological rovers, the ones that were the first ones to be fully equipped with the instruments that we need to really act as geologists on Mars, were a twin pair of rovers named Spirit and Opportunity. They landed on Mars almost 20 years ago. And even though they were supposed to last for only 3 months, Spirit ended up exploring Mars for something like 6 years, and Opportunity went for 14 years, telling us about the geology and the history of Mars. You know, one of the reasons I really love the rovers is the kind of pictures that they send back and how they have the ability to really show us that Mars, it's a place, and it's a place that if you kind of squint and tilt your head to the left, it looks like it could be very similar to some places on Earth, some very dry places on Earth. And I love that. I could almost imagine when I see pictures like this, walking on the surface myself and running my hands through the Martian dirt. Another amazing thing about the rovers is that the pictures they send back are always surprising. So when we had kind of our first views of Mars, they were from landers called the Viking landers, and the first little rover to ever land called Pathfinder. And then even from Spirit, we got pictures of Mars that kind of looked like this. We saw the planet was really dusty. It was covered in this layer of rusted dust. And then there were these sharp black rocks that were poking up through that had been sculpted and shaped by the wind. And this is kind of what I thought Mars looked like everywhere. And then Opportunity landed, and this was the view of Mars that we saw for the first time from Opportunity. And it is just so different and so amazing. And I will say, when this image came back, I actually had a wonderful opportunity to be participating in a program, an outreach program, that brought me to the Jet Propulsion Laboratory here, to this very building I'm sitting in today, to see with the science team as the first images from Opportunity came back. And there's actually a picture of me watching this come down. And this blew my mind, because this really helped me understand that Mars is this incredible place, and we have so much more to explore and so much more to see. And this was the sort of image that sparked my interest and made me want to have a job where I also got to drive rovers on Mars and to explore and to see things that no human had ever seen before. Opportunity was an incredible rover, and going back to just how long it operated, it was designed for 3 months. It wildly surpassed all expectations and ended up roving for 14 years. And this is actually a picture of Opportunity's route that it took on the surface of Mars. That white line is the route that the rover drove. It drove over 42 kilometers over the course of its life. And it might be a little hard to see, but I marked little circles at key points that are things that I did in my career while Opportunity was roving. So I was a high school student when Opportunity landed on Mars. I then graduated high school. I went to college where I studied geology and physics. I graduated college. Opportunity was still going. I went off to graduate school where I wanted to study planetary science. When I was a graduate student, I actually got involved in the Opportunity mission as a science team member. Several years later, ended up earning my PhD. Opportunity was still going. And then I came out to California, got a job at JPL, and Opportunity was still going. And so at that point, I was appointed in a role called the Deputy Project Scientist of the mission, where I got to help manage the science team and manage the interactions between the science team and the engineering team. So what an incredible mission that it was operating for that long, that I could go from a high school student to actually being very deeply involved in it. And before I wrap up on Opportunity, I do want to give just a little bit of a shout out. There is this amazing documentary that will be coming out soon. It's actually coming to selected theaters next week, but it will be streaming worldwide anywhere on Amazon Prime starting November 23rd. And this tells the story of Spirit and Opportunity. It tells the story of the team that built and operated these rovers for so many years. And if you are excited about Mars exploration or space, I highly recommend watching it. It's a wonderful film. And it shows, I think, some aspects of this space mission that haven't really been seen that much before. But what do I do now? Now I spend most of my time on a newer Mars rover called the Curiosity Mars rover, which landed on Mars 10 years ago. And to give you a sense of this rover, here's a picture of sort of the evolution of Mars rovers. This one in the front here, this little tiny one, this is the first rover that was ever sent to Mars, and it just kind of proved that we could rove on Mars. Then we sent Spirit and Opportunity. They're about the size of a person. These were our robotic geologists that really looked at the rocks. They told us about the history. They told us really for the first time that yes, Mars once had liquid water on its surface, which is one of the ingredients that we know life needs. But then we jumped all the way over to this giant rover, Curiosity. It's almost the size of a small car. And Curiosity is our mobile geochemist on the surface. Curiosity is so big because we have instruments that need to be that big in order to really tell us really detailed information about the rocks. And what we're looking for now is whether Mars once had environments that had all of the ingredients that we know life would have needed to start. So in addition to liquid water, looking for things like sources of energy that life could have used, and things like organic molecules. These are molecules that have carbon in them. These are the building blocks that we know life needs. Curiosity landed in a big old hole in the ground on Mars called Gale Crater. And what's really cool about this big impact crater, this big hole that a meteorite slammed into and carved out, in the middle of it, there's this big mountain of rock. And we can see from orbit that there's actually layers in this mountain of rock. And we realized that if we landed at the base of this mountain and we climbed our way up it, we'd be able to read the rock layers, much like if you go to a place like the Grand Canyon in the United States. There's all these layers of rocks, and you can hike down the canyon and you can go back in time as you get to older and older rocks, lower and lower in the canyon. We're doing the same thing with Curiosity. And we can tell that each one of these different layers records a different snapshot in Martian history and gives us an opportunity to look backwards in time and to see all the kinds of environments that would have been there that changed through time. When Curiosity landed, this was the first view that the rover had of Mount Sharp. We couldn't land on, the mountain is called Mount Sharp. We couldn't land on the mountain itself because it was too rocky and steep. So instead we landed on the flat part away from the mountain. But even as soon as we landed, even though we weren't even at the mountain yet, when we looked down, we saw rocks that looked something like this. And we got really excited because what you can see here are these rocks are made up of lots of pebbles, big pebbles that have been rounded. And the kinds of environments that you get rocks like this on Earth are riverbeds. And so here's a picture of a riverbed rock on Earth, and you can see how similar it looks like to the riverbed rock that we found on Mars. But looking off to the mountain, we were able to look at it with the rover's telephoto lens, zoom way in to see all of the layers. And what we saw was the mountain was indeed layers. We could see all of these layers and layers and layers. And then when we finally reached the lowest part of that mountain, what we found was that the layers had layers. The rocks here were made up of lots and lots of really fine layers, really fine grains in those layers. And the kind of environment that you have when you get rocks that form like this is something where you have water that's very quiet, like a lake. So we realized that this crater once had rivers that flowed into it, and that's what we saw on the plains when we landed, and that eventually pooled and formed this lake, which would have filled the crater about 3.5 billion years ago. And as we've continued to climb the mountain, what we found is that this lake stuck around for a really long time. We think the lake was there for probably tens of millions of years. So not only was there liquid water, we think the water in this lake was drinkable. We have found those organic molecules that we were interested in finding, and this was all around for tens of millions of years. So we know all the ingredients were there on Mars to have formed life. So it's a very, very exciting finding. We do a lot of neat things with Curiosity. As I said, we're a chemistry lab, so we analyze powders from rocks. To collect those powders, we actually drill into the rock. And here's a beautiful mosaic of the 36 times that we've drilled into the rock so far. And you can see one of the things I love and that we've learned, which was surprising, was how colorful Mars is. Mars at the surface is the red planet. It's red because it's covered in this all oxidized dust. But when you get below the surface, you actually find Mars is gray and purple and a little bit greenish and all sorts of different colors. And it's the differences in the minerals in the rocks that's causing these different colors. More recently, we've been having a lot of fun getting some scenic views. We're pretty high up the mountain now. Here's a simulated view of the rover with some of the real rover data kind of in 3D, just showing the spectacular area we're in. There's these big rounded hills all around us. And this is an actual photo that the rover took from that same location. Driving has been a little bit tricky at times. There's lots of sand that we have to be careful not to get stuck on and big rocks that we need to avoid. But we're learning so much looking at scenes like this and just the spectacular beauty that's there too. I love it. Here's another image from a location where we were just a week or two ago. You can tell even this looks quite different, but still seeing lots of layered rocks. But one of the things we're finding is that the rocks are changing. They're no longer rocks that were deposited in a lake, but instead they're rocks that are becoming saltier. So we're trying to understand, is the lake drying up? Is that's what's forming all these salts that we're starting to see? And what does this all mean? If there had been life on Mars, how hard or easy would it have been for that life to continue to survive in these sort of drying conditions that we're observing in this section of the mountain? And then I'll show you, this is what I was doing about half an hour ago. I was looking at this image. This is the data that we have from the rover that came down this morning. This image, it's available on the web. I actually downloaded this from the public website. As soon as we get data down from the rover, we post it immediately. You can tell there's a lot of things that seem to be missing from this image. It's just because we didn't have the big enough downlink capability from Mars this morning to get the whole scene. But right now, all of the science team members are looking at what we can see here, and we're deciding where do we want to do our investigation on the rocks? Where do we want to shoot the laser? Where do we want to put the arm down to get the hand lens view close-up image of the rocks? And those decisions are going to happen throughout the day. We're going to put them together into a plan for what Curiosity does for today. We're going to make sure that that plan fits in terms of all of the time and the power that we have available for us on this Martian day. And we'll come in on Monday morning, and hopefully we will have driven to a new location and we'll get to see a brand new site on Monday. But wrapping up, I want to talk a little bit about what's next for Mars exploration. And it's a very exciting time. We've answered the question with Curiosity that life could have existed on Mars. And so the next question that we really want to answer is, can we find evidence of life on Mars? And to do that, we think we need to bring very carefully selected rocks from Mars back to Earth to investigate them in our scientific laboratories. So we're sending this whole fleet of spacecraft to do that. There is another rover that you see here. This is called the Perseverance rover. That's the first step. Perseverance will actually collect all of the rocks that we think are the coolest and the most interesting to send back. Then we're going to send in a couple of years another pair of spacecraft. It's going to be this really cool helicopter looking thing that's going to drive around and pick up the rocks that Perseverance has collected. And then also a rocket that's going to be able to land on Mars and then take off from Mars and shoot off and bring those rocks back to Earth. And then finally an orbiter that will collect the rocks from that rocket and bring it back to Earth. So it's a very exciting time. It's going to take a few years, but Perseverance, that first step, that it has begun. Perseverance landed in February of last year. Everybody was very, very happy at the landing. And then here is a picture that Perseverance took, its own kind of selfie on Mars. There's Perseverance and then its cute little sidekick technology demonstrator helicopter named Ingenuity in the back there. And what's been really exciting is how successful Perseverance has. It's starting to collect those rocks. Perseverance doesn't just like grab a rock off the surface. Instead, we're drilling into the rocks. We're collecting these rock cores that are about the size of a piece of chalk, and then hermetically sealing them in tubes that are going to be very sterilized and protected as they're brought back to Earth. Here are some of the pictures of the rocks that Perseverance has collected. This is an out-of-date photo. Perseverance has actually collected over 14 rocks so far, and I think it's really fun to look at how different they all are. Some of them are from volcanic environments, some of them are from lake and delta environments, and all of them are going to tell us a lot about the history of Mars and help us in the search for life on Mars. I'll just wrap up and say that you too can explore along with the rovers in real time. All of the pictures that Curiosity and Perseverance take are posted automatically. There's just, a process just does it without any humans to the World Wide Web. So you can just, Google Curiosity latest images or Perseverance latest images and see them come up. We also write mission updates where we blog about what we do every day, and Perseverance has occasional updates explaining what they're up to. And so if you're interested in following along, check out these websites or just go to mars.nasa.gov to find out more. And with that, I'll wrap up and happy to take any questions.
Dr. Abby, that was, I've hosted you, I think, 10 times at this point, and every time I learn something new because you share these incredible new images and stories from Mars. It's breathtaking, honestly. Like the sight of the mountains in the distance looks like something you'd see in Jordan or Chad, and it's on another world, and we have that picture instantly, and it's just, my face hurts from smiling when I do these programs with you. So thank you so much for all that. Alas, I had said at the beginning we were doing a Kahoot, and it decided to completely fail as we were getting it ready. So what I'm going to do, this tech likes to mess with us sometimes. I'm going to make sure everyone has that Kahoot link at the end of the broadcast. If you want to test your understanding with some quick questions, that's a fun way to keep the engagement going. What we're going to do now is dive in with some questions. So I know I've got some groups on YouTube. If you guys want to share in the chat, please do. Our John Black Badgers crew live with us. Get ready as well. But Dr. Abby, just to begin, again, you mentioned that we get these latest images and they go straight to the web, which is mind-blowing. How does it feel, even so many years in doing this incredible work, to see an image that's just been captured on Mars? Like for you personally, what is that emotion like for something that you've worked on the mission, you were involved in the creation of this thing that's on another world and it's capturing this image? What does that feel like?
Oh my gosh, it never gets old. You would think after 10 years, okay, it's just another rock, whatever. No, it never gets old. It's so thrilling because, you get the realization that you're seeing something that no human ever in the history of the world has ever seen before. We are the first people to see these particular rocks. And it's really fun for me if there's certain things that I see a rock in that black and white image and I say, oh, you know what? Can we get a color picture of that? Can we get a really high resolution color picture of that? I think that rock is really interesting and I want to learn more. And I will be like waiting for the data to come down. I'll see when it's supposed to come down. And I'll be hitting refresh, come in. And it's so exciting to see things resolve and see the detail that you weren't able to see before. I love it.
Spectacular. Let's head to our John Black Badgers crew, Miss Matheson's class. If you guys want to come on in for a live question, you're good to go. Hey, guys.
Oh, so many questions. Okay, Sophia.
Hey, Sophia.
Hi. How many rovers have you sent to Mars?
Yes.
Oh, good question. So let's see. The United States has sent rovers named Pathfinder, Spirit, Opportunity, Curiosity, and Perseverance, 5. And then China actually just sent a rover that is also exploring. So there's 6 total rovers that have been sent to Mars so far.
Very, very cool. A quick follow-up on this from Miss Dykstra's class. How many are working right now? So how many are actively, the mission's still ongoing?
So right now, we have three rovers operating on Mars. So Curiosity, Perseverance, and the Chinese rover. There's also a lander on Mars. It doesn't have wheels. It sits in the same place. It's called InSight. But what InSight is doing is it's looking for, we call them Mars quakes. Think of an earthquake, but on Mars. And InSight has also been operating on the surface of Mars for several years now, picking up Mars quakes and learning about the inside of the planet.
Super, super cool. I wanted to highlight something that you mentioned near the end of your talk, the Mars sample return idea. We've been blessed with NASA engineers galore this month. We had Matt Heverly on not too long ago, and he talked about this mission, and he was amazing. So you can check out his link on our YouTube channel as well. Every program we do lives there forever. So if you want to follow up this presentation with Dr. Fraeman and go explore some other incredible NASA scientists and engineers, I really encourage you to check that out. Now, Dr. Abby, we had a class that was all set to join today, and the teacher got sick. So she sent in a bunch of questions for us so that we could get these in. You talked about driving rovers. She did a little research with your past programs too. And so is there any skills you need to drive a rover? Is it easy? Would video gaming help? What's the deal with rover driving?
I don't know. Video gaming might help. But no, we don't actually drive the rovers real time, like with a joystick. Yes. Because Mars is so far away, it takes the signal to get from Earth to Mars at a minimum 10 minutes and then another 10 minutes to come back. So if you were trying to drive it real time, you'd only be seeing things that are 20 minutes old. So, imagine trying to drive the fanciest car you can think of, a Ferrari or a Porsche or Lamborghini, but you can only see the road that you were at 20 minutes ago. You would never do that. So instead, what we do, the way we drive the rover is we write programs and we code and we run simulations and we plan the whole drive at once. And then we tell the rover, okay, go off for 50 meters, get from here to here. And so the kind of skills that you need to be able to do that, programming is really helpful. Being able to know some physics. We like to calculate what the forces on the rovers are before we execute those drives, just to make sure everything is safe. And being really good with computers, I think, is one of the biggest skills.
So for our students that are in coding class, or there's increasingly amazing organizations that help teach kids how to code. When you're doing these things, think that someday in the future, you could end up driving a rover on another planet with those skills, which is very, very cool. John Black Badgers, I'm going to come back to you guys live. We'll take some from YouTube after that. Come on in, guys.
Have you ever went to any other planets?
Personally, no, but we have landed spacecraft on other planets. Russia has landed some spacecraft on Venus, our next door neighbor on the other side. We've also landed a lot of things on the moon, Earth's moon. We have orbiters that are around many planets in the solar system, places like Jupiter. There was one that was at Saturn for a long time. We've flown past Pluto. And there's exciting missions that are going to be coming up in a few years, including a helicopter that's going to go to one of the moons of Saturn named Titan. That's going to fly around on the moon of Saturn. That one's going to be very cool.
Titan's so cool too. So for people that might not know, when we've scanned the surface of Titan, it looks like the Earth kind of. It's got these methane lakes. So it's not water like us, but it's just such a analogous thing with such different materials. So it'd be such an alien world to us, but sort of looks vaguely similar. So some spectacular missions on the go. Some of the missions you referenced, so New Horizons, Cassini, we're looking into the Europa Clipper concept. The Voyager missions have always been my favorite back in the 70s. And so really, there's a lot of fodder for any kids that are keen to look about how we've gone about exploring our solar system. Very, very cool stuff. Miss Dykstra's class has a whole bunch of questions. So when you take rock samples, what are you looking for? Are the metals, the rocks similar to what we'd find on Earth?
Oh, good question. Yeah, there's a lot of things we look for. The biggest thing we're looking for in the rock samples is we want to get a whole different kinds of rocks. So we want to sample the maximum diversity that we can. One of the things that we're really excited about would be rocks that formed in watery environments that are very, very fine grained. And in particular, that have clay minerals. Those are the kind of rocks that we know are going to be the best at capturing little pieces of life if there ever was life on Mars. It's very good at capturing and preserving that kind of evidence. In terms of the composition of the rocks on Mars, what's amazing is that Mars rocks are made of the same stuff as Earth rocks. The same kind of rocks you get in a place like Iceland or Hawaii, where there's a lot of volcanoes that are coming out from deep under the ocean. Those are the exact same kind of rocks that we find on Mars. And that's something that I think about a lot. And just I find so fascinating that these are two completely different planets, but fundamentally they have kind of the same stuff.
Yeah. Well, when I go to my honeymoon in Iceland in a couple of months, I'll be sure to think of it as Mars when I'm walking around, and I'll say that I have you as a backup scientifically for this. Perfect. Very, very cool. This is, as we've explored more in our solar system, finding out how the things are related, how it's all that same stuff has been really quite incredible. The moon in particular, I find fascinating. The origin story of the moon. I hope our students take the time to check that out when they're done. But again, great question, Ms. Deicher's class. All right, from our class that had to stay at home today, day by day, does your work change as you do things throughout the year, throughout every month? Do you do similar things every day? What does it actually look like to be a researcher?
Oh gosh. Yeah, no, my work is parts of it are the same and then parts of it are very different. So I spend a lot of my time helping to drive the rovers. And in terms of the mechanics, we have a very set procedure for how we operate the rovers and what kind of meetings we have and how we put a plan together. And that's the same. But the kinds of plans we put together and the things we're finding and the decisions we need to make about what we want to do next, that is different every day. And then some days things don't work and they go wrong. And so we have to figure out how are we going to work around this problem? Maybe we don't get the data we thought we needed, or maybe we find one of the mechanisms on the rover didn't work quite as we expected. And so that's always a very interesting day, problem shooting and trying to solve what's happened.
Well, so for me, the Kahoot fails and I can send it the next day. It must be very, a little stressful when something goes wrong or oh, this didn't work or this didn't work the way it should have. I mean, that's got to be a lot of people panic a lot more than in the science communication world. So I'm glad there's people like you on the case who can come in very calm, cool, collected. And we've done this before and solved the issue. Let's head to YouTube. A few more questions, everybody. This has been such a fun opportunity. I love these programs with you every time, Abby. Ms. Deicher's group. So a question we get in a lot of our space programs: do you hope to become an astronaut? Would you have the qualifications to become an astronaut? If you could go to space, would you?
Oh, yeah, I would love to go to space. I think that would be so cool, but only if I could be promised a return trip back home to Earth. But yeah, if I could get the opportunity to walk Curiosity's traverse in person, I think that would be fabulous. And actually, I'll have to brag. We're so excited. One of the members of the Curiosity team named Jessica Watkins, she did her graduate work and her postdoc work on data from Curiosity. And then she was actually selected to be an astronaut and then actually flew into space. And so she spent the last 6 months on the International Space Station and just got back to Earth. I think it was last week. I was very nervous, but she made it. And we're so excited about her, so excited, so proud of her.
That is such a nice sentiment and something that, again, we've had echoed on the YouTube, the idea of how many colleagues you get to work with. Space exploration takes a lot of people, and it usually takes an international community. And the relationships that we see among people in these, in NASA and the European Space Agency, across these agencies around the world is so, so special to work with people that you're with for a decade and you're so dedicated and you're passionate. It's why the control room videos are always people losing their minds with excitement when the thing lands, because it's such a special thing. Where else in the world, what other kind of job do you have people spending such a long period of time together on something that is such an important thing for mankind's exploration of the universe, and then you see it come to fruition? It's just such a magical moment. So I'm so glad you shared that, and I hope you get the opportunity. You mentioned walking on Mars, and I mean, our kids in our classes today are likely to be the generation that are the astronauts that go to Mars. So if you're watching this and you're keen, I mean, what do you think about that? Do you agree? I'm curious.
I sure hope so. We're learning more and more about how to do it. And, we're planning to first return to the moon and then go on to Mars. And so I sure hope so. And man, wouldn't it be so cool if one of you watching today was the first person to step on Mars? I think that would be amazing.
Fingers crossed, fingers crossed. John Black Badgers, if you guys want to come back in with one final question before we wrap up, time flies and you're having fun, but let us know. Hey.
What happens to the bots on the planet when they stop working?
Great question.
Yeah, so they stay there. You know, they were built and designed to operate on Mars. That's kind of their home. And we're not going to go and bring them back. If we could bring back that much heavy stuff, we'd probably fill our bags with rocks and not robots. And so we just leave them on the surface of Mars. What's incredible is that because Mars is so dry, they're not going to rust. They're not going to fade away. They will probably be there for millions and millions of years until, you know, maybe one of you comes back and moves it, or maybe you'll make a national park around it. I don't know.
I've actually always loved this idea. A book called Artemis by John Weir, who did or Andy Weir, who did the Martian movie. It talks about this, going to the moon or going to Mars and having as historic sites, places that tourists can visit, these robots long after their missions are done. And I think that's such a beautiful idea to sort of intuit ourselves into the future in that way. Dr. Abby, this has been so much fun. You did highlight mars.nasa.gov, and I want to stress for kids that are keen to learn more about Mars, we can always take these questions all day long. Go check out that website. There's so much to explore and discover. NASA is better than any organization in the world at translating the stuff they do and making it accessible, exciting for kids. So I really encourage you to check that out. Before we go, I want to ask one question of you and get you to do one thing for me. You've got this fancy thing behind you, and I'd love you to show us a little bit about that guy. And then after you tell us about that, if there is any final message you want to leave our kids with to go explore Mars after they're done, please do. But what is this thing?
Yeah, I just wanted to show this off. This is just like, you know, lying around my office as it does. This is actually a Mars wheel. This is a wheel that is similar to the ones that we have on Curiosity. And I hope you can see just how big it is. You can see my whole face through there. But this is just one wheel on the rover. We have 6 of these driving the rover. So hopefully this gives you a little bit of a sense of scale of how big Curiosity is. And you can see there's actually even a special pattern in the side of the wheel, a bunch of dots and dashes. This is actually, if you know Morse code, you could look at these dots and dashes and they spell out the letters JPL. So we're writing the name JPL in the soil on Mars everywhere we go.
That's the nerdiest thing I've ever heard. I love it.
Yeah, it's great. But yeah, I mean, and if I just want to give you all one message, a lot of questions I get sometimes is, how can I go into space exploration? And I think my best answer is to just follow whatever path it is that you are passionate about and whatever you're passionate about doing. You know, there's a lot of scientists and engineers who work for NASA. And if that's what you love, you should definitely go into those fields and any kind of science and any kind of engineering. We need all of them here. But if you like telling stories, if you're an artist, we need those kinds of people too, in order to communicate what we're doing, in order to share the beautiful images of what we're achieving. So there's all sorts of different pathways to go to be part of space exploration. And the best way to get involved is to do what you love to do. And that kind of a pathway, I think, will lead you to where you want to go.
Abby, thank you so much for joining us as always. Stick around after the broadcast for a quick minute, but I want to say a big thank you on behalf of myself, our YouTube crew, and John Black Badgers. If you guys want to come in and join me in saying a big thank you and farewell, you are in the broadcast. Thank you so much, everybody. Have a wonderful day.